talking about a logarithm. So we know that exponential functions and logarithmic functions are inverses of one another. We saw that yesterday. Yes, and you've seen that in the past. So if we have y equals 2 to the x, the inverse function of that is the log with the same base, so the base of 2. Okay, and this is what it looks like graphically. Notice we always have that line of inverse where y is equal to x. The common logarithm we know means that it has a base of 10, and we don't show it. Okay, you don't write the base of 10. So if you see no base there, you know that it's the common log. It has a base of 10. Now, natural logarithm. This is something, I can't remember, I don't think you guys did this in exam. I can't remember, but that is when you're looking at the exponential function e to the x. What's e? We learned e yesterday. What did we talk about? What's e? Whose number is it? What's his name? Yeah, good, right? Euler. Right? Euler's number. I don't know, that's how it's pronounced. I don't know. Okay, so, yes. What was I going to say? So, we have the special number. What is that number? What's the decimal?
About 2.7.
2.7, good, about 2.7, right? 2.7 is approximate, 2.718, yes? Or just 3 digits, that's not. All right, so the natural logarithm is now a log with the base of e, we call that log. Okay, log with the base of e, we call it log. So if you see log of x, you know that it means it has a base of e. Okay, let's talk about log properties. So a log is a log. A log is a log with base e. So we're going to see how these properties relate. So if you have a log with a base of b and it's just 1, we know that it equals 0. Because if I change this to exponential form, b to the exponent 0 is 1. Well, it's the same for log. Because log is just a log with base e. e to the exponent 0 is also e to the exponent 1 is, e to the exponent 0 is also going to equal 1. Okay, log with the base of b is equal to 1. And again, that's because b to the exponent 1 is equal to b. So the same with here, e. Remember, this is just this. So, so the log of e is equal to 1. Over here, log with the base of b to the x is equal to x. So similarly, if you now have this, just so you guys can see the similarity, it will also equal x. Okay? You see the base of your argument is the same as the base of your logarithm. Good. Now you have your base to the exponent log base b of x, and we've learned in the past that that is just equal to x. So the same for log of base b. If you have e to the log of x, it just means that it's a log base b of x, and so it also equals x. We know that if you have an exponent in your argument, log base b of x to the exponent n, you can bring that n down. And the same there with your log, right? We know that if you have a product in your argument, so for example, x times y, we can break up those logs and do them separately by adding. So we can do the log of x to the base b plus the log of y to the base b. Well, the same with your log. And similarly with a quotient, you have a quotient in your argument, you can separate them and subtract them with the same base on the log, and we can do that with our log as well. So log of x to the base b minus log of y to the base b is the same, okay, as log of base b, x divided by y. Are there any questions? So basically, whatever log properties you use, we are also going to use for log. Are there any questions? Does everyone remember these properties? Well, you're going to recall them as you do your homework, right? You're going to have to use them a lot, and they are going to be important. You will need them for your test, okay? Okay, so the inverse of y is equal to e to the x. So the inverse of y, equals e to the x is x equals e to the y, because we know that the inverse is just interchanging the x and the y values, which can be written as y equals log of x with the base of e. The inverse can also be written as y equals ln of x. To find the derivative of y equals ln of x, we will use implicit differentiation. So what we're going to do is rewrite in exponential form and then find dy dx. So if I have y equals ln of x, I know that that's the log with the base of e, and I'm going to change that to exponential form. So e to the y equals x. Okay? And you guys are going to have to be able to go from one form to the other quickly. Right? Good. Okay, so we're taking the derivative of e to the y, right? The derivative of y with respect to x. And so we know that here, if I rearrange this, because we know that the derivative of e is itself, and then we multiply by y, and the derivative of y is dy. Right, we learned that. So there's another way of writing this, guys, just so you don't get confused. It's ey times y prime equals 1. It's the exact same thing. And now we solve for our y prime, as we always do, and you get 1 over e to the y. But we know that e to the exponent y is just equal to x. And so the derivative of your ln of x is 1 over x. And so that's a little proof. And of course, guys, it's not going to always be just ln x. You're going to have more complicated functions than that. And so we're going to use the chain rule as we always do. So, example 1. Y equals ln of 3x plus 1. Okay, so we just saw that the derivative of ln is 1 over x. So now, the derivative of ln of 3x plus 1 is going to be 1 over 3x plus 1. If you had to guess, what do you think I have to do here? What do you think the next step is, if you had to guess? You're going to multiply by the derivative of your argument.
Miss, I have a question.
Sure.
So we can just memorize that ln of x is equal to 1 over x, right?
Correct.
Like we don't have to show?
No, I will never ask you for a proof.
Okay, thank you, Miss.
No problem. I will never ask you for a proof. Okay, and now here I have y equals 2 ln of x to the exponent 4 divided by x cubed. So before I take the derivative, I would like to simplify it because I want to make my life easy. So how can I simplify it? What do you guys think? Before I take my derivative, I want to simplify it. Let's use a property.
Bring 4 down.
Good, we're going to bring the 4 down. So 4 times 2 is 8. And so we have 8 ln of x divided by x cubed. And now we're going to have to use a quotient. So the bottom times the derivative of the top. Well, I have 8 times ln of x. What is the derivative of ln x?
1 over x.
Yeah, it's just 1 over x. And it's being multiplied by 8. So it's just 8 over x. Minus 8 ln of x multiplied by the derivative of your denominator, which is 3x squared, all over your denominator squared, which becomes x to the exponent. And now we just need to clean it up. Who wants to do that for me? Nice and easy. I've got an x cubed multiplied by 8 over x. So that becomes 8
X squared.
Thank you. Perfect. And then I have a negative 8 ln of x multiplied by 3x squared. So that -8 is your coefficient, and so I'm going to multiply it together with my monomial. Now, we know that whenever we simplify our derivatives, we always want to factor. So is there anything that's factorable here? Can I factor anything out? Any GCF?
8x squared.
Perfect. And am I done? Oops,
No, you
No.
can simplify with x squared and x to the 6.
excellent. There you go. And that's what we do. Okay, so let's put a note here. Use log properties to simplify. Before finding y-axis. Now, if you don't, you're still going to get the same answer. It's just easier if you simplify it. You're just making your life easier. Okay, now I've got y equals ln of 1 plus x over 1 minus x. What can I do here? Look at my argument. What can I do here?
Rewrite it
Yeah.
into 2.
Excellent. That's exactly what I want to do. And because the argument is a quotient, I can subtract by the same log, which in this case is a base of b. And now I can take the derivative, which is much simpler, right, than having to worry about a quotient. So for the derivative of ln of 1 plus x, does anyone want to try? Anyone at home want to try?
1 over 1 plus x.
Good. And then times 1, because the derivative of x is 1, but you don't have to show it. And then minus 1 over, the same here now, right? And now the derivative is -1, so you must show it. Because it's going to change your answer. What do we need to do from here?
Common denominator.
Yeah, you need a common denominator. Remember, guys, to be fully simplified, we want to bring it together as one fraction. So my common denominator here, I'm just going to bring the two together. I'm not going to worry about factoring out the negative and putting x. First, it's not necessary. So if I'm finding a common denominator, what happens to that first fraction?
You have to multiply it by 1 minus x.
Good. 1 multiplied by 1 minus x. And then on the other side, it's going to be -1 times 1 plus x, correct? But hold on a second here. We've got two negatives, yeah, that give us a positive. Cleaning this up, what do we get?
2 over 1 plus x, 1 minus x.
And that's considered fully simplified. Any questions so far? Okay, D. Now we have y equals e to the exponent ln of 3x minus 1. What should I do here? Does
Take the
anyone?
derivative.
Yeah, we're gonna take the derivative. Should I take it right from now though? Can I
I think
simplify this?
rewrite it in like log form.
Yeah. So, well, so we know that this, just so you guys can see it, 'cause I know you guys have a hard time seeing it. This is just log with a base of e. Yes, that's what ln is. Log with a base of e. And now, can you relate that to any of your log properties? Go back to your log properties. We know that when the two bases are the same, it just equals. Yeah, you got it. And so now when I find my derivative, it's nice and simple. It's just 3. Okay, so always to look to simplify first, okay? Find the equation of the tangent line to the curve f of x equals e to the exponent negative x ln of x when x is equal to 1. So for finding the equation of the tangent, we need a slope and a point. I have an x value, I need to find the slope and my y for it, yes? And then we can find the equation of a line in either standard form or y equals mx plus b. Okay, so finding the derivative. What kind of rule do I have here?
Product rule.
Yeah, product rule, excellent. So, the first, find the derivative of the second times the derivative of the first. Does everyone follow? And now we want to clean it up. One over x e to the x minus. Now, it's not necessary to go any further than this because the whole point of this is to sub in 1 and find out what the slope is, yes? No, because remember the derivative of e is always itself and then multiplied by the derivative of the exponent. So if the derivative is itself, e to the negative x, and then you multiply by the derivative of negative x. Okay, so subbing in here, I'm left with 1 over e, and then minus ln of 1 over e. What's ln of 1?
0.
Add 0. And I'm just showing it so that when you guys go back to your notes, you understand why. Okay, so that means the slope is 1 over e. You never sub in. We're not going to sub in Euler's number. We are just going to use 1 over e, okay? We treat it just like pi, okay? We're not subbing in. We're going to keep it as it is. So I have the slope. When you sub in 1, guys, what is your y value?
0.
Good. So let's do it. I want to do it actually here just because I know that this is new for you guys. So if you have your y, and you have e to the exponent negative 1 times the ln of 1, and we know that the ln of 1 is 0. And so I have the point 1 comma 0. And so now I'm ready to find my equation. This, guys, generally, when you're dealing with ln, they're in y equals mx plus b. Okay, that's usually the way we show them, but that doesn't mean that we can't ask for standard forms. But generally, they are in y equals mx plus 2. So that's what I'm going to do here. I know that y is 0. And so solving for b, I see that it equals negative 1 over b. Therefore, y equals your slope, which was 1 over e, times x, plus your b, which is negative 1. Are there any questions?
So Miss, for standard form, would we multiply each side by e?
Yeah, you would. But it's
Okay.
not common to do that. But yes, you would. You would multiply everything by 2. Good. Okay, guys. So your homework for this section is this. For 4F, there is an error in the textbook solution. And so the correct answer is this.
Miss, are we doing another lesson today?
Yeah, we're going to do 5.2.
Okay.
And then tomorrow, we're not going to do any lesson, okay? Tomorrow will be just a review day for you guys. And it's not a long lesson, 5.2. It's just the derivative of a to the x now. So a regular exponential function where your base is not e, because it is different.